Good morning, students. Once again, I welcome you all for this another session of numerical problem solving on cable structures. So today, one more interesting problem we're going to solve, and the problem is like this: a footbridge 3 meter wide is supported by two suspension cables with central dip of 3 meter and horizontal span of 30 meter. Determine the maximum and minimum tension in the cable. Also determine the length of the cable and cross-sectional area of the cable. The footbridge has to carry a load of 10 kN per meter square. Permissible stress in the cable is 120 MPa, that is Newton per mm square. Determine the horizontal and vertical reactions at each end and also the maximum bending moment for the pier if the height of the pier is 15 meter. Take inclination of the anchor cable is 30 degree. Again, two conditions. For these two conditions, we're going to find out the different things. One is the cable passes over a pulley, and second one is the cable passes over a saddle. So as per the given problem, first we're going to draw the sketch. So AB are the two supports, okay, and these two supports are separated by a distance 30 meters. So capital L, that is span is 30 meter, okay. Then as usual, central dip is given, small h is equal to 3 meter. Okay. Now let us see this figure. So here UDL I have shown, right? How you have got this 15 kilonewton, because this is not mentioned in the problem. Okay. Okay. So how we have drawn this UDL and what is the intensity of UDL, that we are going to find first. Okay, again as usual, central point of this cable is point C. So the total span is 30 meter, means it will be 15 and 15. Okay, and let us see this here. This is given a foot bridge. Okay, so this is a small bridge of length how much? 30 meter. So on this bridge there will be a moment. Okay, so both side cable will be there. So this is one side cable, that is here the cable will be there, and this side also there will be a cable. Okay, so this is the foot bridge. Over this there will be a moment of a vehicle or person. Okay, now how to find this load now, load on the cable, that will be interesting here. So first we're going to find out weight of the cable. Okay, first we'll find out weight of the cable. So whatever the weight on this bridge, okay, whatever the weight of this bridge will be transferred to this cable and this side cable. Okay, so first we'll find the area of this footbridge. So area of the footbridge A is equal to, capital A is equal to 30 into 3. So what is 30? Length of the bridge, 30 meter is given in the problem. Okay, so a bridge, footbridge 3 meter wide, that is 3 meter wide, supported by two suspension cables with a central dip of 3 meter and horizontal span of 30 meter. So whatever you are seeing, this 30 meter will be this 30 meter span. So what is the area of this bridge now, footbridge? So it is 3 into 30. So 30 into 3. So that is 90 meter square. Okay, the bridge has to carry a load of, okay, 10 kilonewton per meter square. Here it is given. Okay, the footbridge has to carry a load of 10 kilonewton per meter square. Try to understand this. Means for every 1 meter square, right? For every meter square, what will be the load? 10 kilonewton. Okay, for 1 meter square area, load will be 10 kilonewton. So now what is the area of this bridge now? 90. So what will be the force now? So 90 into 10. Okay, load on per meter length of the cable. So for every 1 meter length of the cable, so what will be the load? That is 90 into 10. So 90 meter square is the area. So for 1 meter square, how much load? 10 kilonewton. So 10 into 90 divided by length of the, that is horizontal span here in this span. Okay, so for every 1 meter area, what will be the load? 10 kilonewton. So the area is 90 now. So 90 into 10 divided by this span. So you'll get 30 kilonewton per meter. So load on cable per meter length. So means for 1 meter length of the cable, 1 meter length of the cable, how much load? 30 kilonewton. Okay, this includes on both the cable. So one cable is here and one more cable is here. So for two cables, how much load? 30 kilonewton per meter. So now we can calculate for one cable how much load? This divided by 2. This is for two cables. So for one cable how much? Okay, so load on per meter length of the cable for each cable, that is equal to 30 divided by 2, 15 kilonewtons here, right? So this is not given in the problem, so we have calculated this. First find out the area of the footbridge, and load is given. How much load the footbridge has to carry for per meter square? It is 10. So 90 into 10 divided by span of the bridge will give load on the two cables. So divided by 2 will give load on one cable, that is 15 kilonewton per meters here. UDL, that this load will be acting, okay, in the form of UDL, that is 15 kilonewton per meter. This is important now. Okay, so once this diagram is drawn, so there are two cables now, here one and this side also same one. Okay, so we'll calculate per cable. Okay, it will be remain same for the other cable also. Now as usual, now the procedure remains same. First we'll calculate the reactions. Okay, in that first vertical reactions, that is VA and VB. So now see again, the load is symmetrical throughout the span. Load is 15. It is symmetrical. Now VA is equal to VB is equal to total load divided by 2. Okay. Now see. So since the load is symmetrical, VA is equal to VB. So therefore VA is equal to VB is equal to total load divided by 2. So what is total load? Convert this UDL into point load. So 15 into 30 now. 15 into 30 will be the point load here. Okay. So whatever the point load is there, half of that load will be taken by this reaction, half will be taken by this reaction. Means what is the total load? 15 into 30 divided by 2 will be the load taken by each reaction, that is VA is equal to VB is equal to 225 kilonewtons. Since load is symmetrical, VA and VB are same. Okay, this is vertical reaction we have found out. Next, similarly, horizontal reactions, that is HA and HB. HA and this side it is HB. So when we are calculating horizontal reactions, you can take only half portion of the cable. Okay, so from A to C. So this is point A to C, half portion, or you can take even B to C also, no problem. Either A to C or B to C, only you have to consider half portion of the cable. Okay, and as usual, we have already found out this VA and HA. So VA we have found out and HA we will going to find out now. This is not known now. Okay, so again half load, half UDL, that is 15 kilonewton per meter over a length of 15 meter. This dip is 3 meter. Now if you want to calculate a horizontal reaction, so take only half portion of the cable and use equation summation MC is equal to 0. Moment at C is equal to 0. Okay, so now summation MC is equal to 0. So with reference to C, this HA will going to produce anti-clockwise. So minus HA into 3. So this is a perpendicular distance between HA and point C. So minus HA into 3. Then this VA, this is clockwise now. VA into, what is the distance now, perpendicular distance? 15. So VA into 15. Similarly this UDL. First convert this UDL into point load. That is 15, intensity is 15 and it is length 15. So 15 into 15 becomes point load here now. Half of this 7.5. So minus, with reference to this will be anti-clockwise. So minus 15 into 15 becomes point load, and distance between this point load and C is half of this, that is 7.5. So this is summation MC. This is equal to 0. So from this I can find out HA is equal to 562.5 kilonewton. This HA will be 562.5 kilonewton. Similarly, HB will be same. So HB is also 562.5 kilonewton. HA and HB will be always same. Whatever may be the load, HA and HB same values. Okay, right. So this is finding out vertical reactions and horizontal reactions. So once if you found out these two, then as usual the next thing they have asked maximum and minimum tension in the cable. Okay, so try to understand where the maximum tension will be there and where the minimum tension will be there. As you know, already know, when you consider the complete arch, cable, so maximum tension will be always at the support and minimum tension will be at the center point of the cable. So maximum tension, first we're going to find out maximum tension at supports T max is equal to, already we know this formula. Okay, if you want to find out T here, maximum tension, then it will be root of VA square plus HA square, under the root VA square plus HA square. So already calculated VA, here HA we have calculated, substitute this, maximum tension at support is equal to 605.83 kilonewton. Okay, and where is the minimum tension now? At center point of this cable. Okay, so minimum tension at the center of cable, T minimum is equal to, so here only one force. Okay, so this VA will be 0 here, VA will be 0, only HA or HB will be there. So what is T minimum? It is square root of HA square or square root of HB square. Okay, so let us substitute. T minimum is equal to, HA already we have calculated, HA and HB are same. Okay, so HA is equal to root of HA square. So from this, minimum tension is 562.5 kilonewton. This is at the center of the cable. Maximum tension is at the support of the cable. Okay, right. Next, length of the cable. Okay, another quantity they have asked, length of the cable. So length of the cable means this. This is not the length, this is span. So length of the cable is this. Okay, from A to B. This will be the length of the cable. Okay, so what is the length of the cable expression? Length of cable LC. See here, LC is equal to capital L, that is horizontal span, okay, plus 8h square divided by 3L. So L is span 30 meter, 8, 30 plus 8, H dip 3 square divided by 3 into again L is span. So from this, length of the cable is equal to 30.8 meter. Okay, 30.8 meter. This is another quantity. Next, they have asked find out the cross-sectional area of the cable. Okay, so for this we are going to consider, it is given that permissible stress in the cable. Okay, permissible stress in the cable, it is given in the problem 120 MPa. So means that each cable will going to take a stress of how much? 120 MPa. MPa means megapascal, or it is nothing but Newton per mm square. So stress sigma is equal to 120 Newton per mm square will be the stress in the cable. So we know that what is stress is equal to? Stress is equal to load divided by area. Okay, sigma is equal to load divided by area. Load means force. What is maximum force? T max. Okay, this load is nothing but force. And what is the maximum force? T max. You should not take T minimum here. Maximum load you have to take. That is T max divided by area of the cable. So therefore area is equal to what now? Area is equal to T max divided by stress. Okay, area is equal to T max divided by stress. So T max, it is already calculated 605.83. Okay, T max, maximum tension in the cable 605.83 kilonewton it is. Now multiply 1000. Okay, if you multiply 1000, what it becomes? It is Newton. So T max is now converted into Newton divided by 120, because this is in Newton per mm square. This top T max should be also in Newton. So that's why you have multiplied 1000. So area will be what? 5048.5 mm square. This is area of the cable. Okay, area of the cable. Okay, so area of the cable is equal to 5048.59. So the cable is, what is the shape of the cable? It is a round cable. Okay, and we know that area of the cable is equal to pi by 4 d square. Okay, area of the cable is equal to pi by 4 d square since it is a round cable. So what is this? Small d, small d is diameter of the cable. So therefore from this you can calculate d. So d square is equal to what? 4 into a, 4 into a divided by pi. Okay, so substitute the values, find out d. So the diameter of the cable is equal to 80.17 mm. Means each cable, right? What is the diameter of the each cable? It is 80.17 mm. Okay, so this is another quantity we have found out. Next, force on the tower. Okay, what will be the force on the tower? For this there will be two conditions. Okay, first one, cable passes over pulley. Okay, so these two cables, that is suspension cable and anchor cable, these two will going to pass through over this smooth pulley. That is the first condition. This is tower, and the angle made by the suspension cable is theta, and angle made by the anchor cable with horizontal is alpha. So it is given, inclination of the anchor cable is, this is anchor cable, inclination of the anchor cable is 30 degree, and inclination of the suspension cable, it is not given, it is theta. Let us take this is theta. First find out the theta. So from this, what is the, how will find out theta now? Take tan theta. Okay, if you take a one triangle here, okay, tan theta is equal to what? Opposite. Opposite divided by adjacent. What is opposite? Opposite means it is a vertical component, that is VA. Okay, tan theta is equal to summation V by summation H, that is VA vertical, VA divided by horizontal HA. Already we have calculated this. So tan theta is equal to VA by HA, will get theta is equal to 21.80. Okay, now once if you get this angle, this alpha is known already, then this T and this T are same. For first condition, these two are same because of this smooth pulley. So therefore first we'll find out horizontal force on tower. Horizontal force on this tower. So resolve this horizontal, resolve this T horizontal. If you add these two, okay, we'll get the horizontal force on tower. So horizontal force on tower is equal to, resolve this horizontal now. What is the horizontal component of this now? T cos theta now. Resolve like this. T cos theta. Okay, what is the horizontal component of this now? T, okay, T cos alpha. Horizontal, only horizontal. T cos theta here, and this T will going to move in this direction, that is T cos alpha. Okay, this is T cos theta plus T cos theta. This is minus T cos alpha. T cos theta minus T cos alpha. So T is maximum tension. Already you have calculated that T you have to substitute. So cos theta is known. This is 21.80. Alpha is given 30 degree. Calculate what is the horizontal force on tower. That is 37.84 kilonewton. Similarly, there is vertical force also. This is horizontal force. Okay. Similarly, vertical force on tower is also. Now for vertical force, okay, resolve again vertical now. These two vertical now. Both are moving in same direction. It is plus now. So vertical force on tower is equal to, now see, if you resolve this vertically, how much it is? T sin alpha, vertical. T sin alpha, and this also T cos theta. Okay. T sin alpha. This is vertical, T sin theta. Both are sin and both are moving in the same direction. It is plus. Okay. T sin alpha plus T sin theta. Okay. So here, therefore substitute the values again, theta and alpha value. Vertical force on tower, you will going to get 527.9 kilonewton. Okay. So both will be there. So first condition, horizontal force is also there. Okay. And then vertical force is also there on the tower. So then one more thing will be there, that is maximum bending moment will be also there. Okay. Maximum bending moment will be there. So maximum bending moment on tower is equal to, okay, maximum bending moment on tower at this point now. Okay, now when you resolve this vertically, that is t sine alpha, then t sine theta. So these two will going to pass through here only. There will be no movement due to vertical component. Only horizontal component will produce the moment at point. So what is the horizontal force? Here you have taken horizontal force t cos theta minus t sine cos alpha, sorry, t cos theta minus t cos alpha. So these forces, and what is the perpendicular distance between these two forces? Height of the tower, that is okay, this. Okay, so therefore maximum bending moment on tower is equal to horizontal force into height of the tower. So horizontal force already we have calculated 37.84 into height of the tower, it is given in the problem 15 meter. Okay, so therefore maximum bending moment on tower is equal to 567.6 kilonewton meter. So for the first condition, okay, when cable passes over pulley, horizontal force will be there on tower, vertical force will be there on tower, and bending moment will be there at the bottom of the tower. These three things will be there for the first condition. Okay, next, second is cable connected to saddle now. Okay, cable is connected to saddle. Okay, so again as usual these values remain same. Alpha remains 30 degree and theta remains 21.80. So assuming saddle to have frictionless rollers, these rollers have frictionless means there will be no horizontal force. Okay, so let us take summation fx is equal to 0 means this horizontal forces component of these two along horizontal forces is equal to 0. Okay, now see, if you resolve this horizontally, plus, okay, t cos theta in this direction, t cos theta, this is plus and this is minus, minus t1 cos alpha. Okay, resolve this along horizontal, t1 cos alpha. Okay, so here one more observation you can make here is this is t, this is t1, these two are not same. Okay, because of this saddle, if it is a smooth pulley, then this t and this t will be same, but here this is a saddle is there, this is t, this is t1. So t already we have calculated, t is nothing but t max, t maximum tension, t1 you will going to find out. Okay, so horizontal component, that is t cos theta plus t cos theta, then this minus t1 cos alpha, that is equal to 0. Summation fx is equal to 0. So therefore t1 is equal to what? T, okay, t into cos theta divided by cos alpha, t cos theta divided by cos alpha. So substitute the values theta and alpha value, you can get t1. So tension in the anchor cable is T1 649.52. Already we have calculated this is T max. Okay, so therefore what is the vertical force on tower now? Again resolve these two forces vertically now. Okay, so both are moving in the same direction, addition of these two vertical component. So this is resolve vertically now. So T1 sine alpha. Okay, T1 vertical, T1 sine alpha, then this is also plus T sine theta. Okay, T sine theta, T1 sine alpha. If you add these two, okay, we're going to get the vertical force on the tower. Okay, so there will be no horizontal reaction and there will be no bending moment. So calculate this. Okay, so keep it the value. So this value, the vertical force on tower, you will going to get 549.74. Okay, actually I have not calculated here, just I have written the expression. Just calculate, you will going to get 549.74 kilonewton. Okay, and horizontal force will be 0 and bending moment will be 0 because there will be no horizontal force here, and if you resolve these two vertically, these two will going to pass through this tower only, no bending moment. So for the second condition, okay, when the cable connected to saddle, only there is a vertical force on the tower, only vertical force on the tower, then horizontal force will be 0, bending moment will be 0. So this is what the problem we have solved. Hope you have understood this problem. Again, if you have any doubt, so please call me or contact me, get your doubts clarified. Okay, so I think this is the important problem. Note down please. So once again, if you can solve this problem, okay, again if any doubts, please let me know. Okay, so thank you very much for attending this session. So one more problem we're going to solve in the next session, and this module will going to be completed. Okay, so thank you very much.